Welcome. This is part B, no sorry, for you not part B, part 2. B is for the regular group. Make a note first. I'll dictate something, right? Very short class, right here. See, some heading are given. Examples exclusively for finding FSC based on epsilon SC calculated for both mild steel and torch steel. Of course, I told torch steel is more important. Now, write the purpose. Once you go through this class, thoroughly understand, in future, you will have no difficulty to get FSC value. Of course, during analysis, there will be trial and error procedure. That will come later. Don't worry about it. So, what you remember is, during analysis or design of WI info sections, both, we need FSC. What is FSC? See, in IS code, they told design stress in compression steel. No. Correct, it is not wrong. IS code has given procedure only for design purpose. Analysis purpose, it is not design stress. Okay, it is not wrong if you call design stress. But the better word is, for analysis problem, your FSC, you can call stress to be considered in steel in compression. Stress to be considered. For design purpose, FSC is called design stress in steel in compression. Finally, what is FSC? Stress in compression steel to be considered, whether it is analysis or design problem. Okay, now, FSC is to be calculated corresponding to strain in steel in compression. You should know what is the strain in steel in compression. So, for that, I told formula, epsilon SC equal to 0.0035 into XU minus D dash divided by XU. What is D dash all will come later. It is, if you can write here, XU you know it. D dash is, you know in working test method, effective cover to compression steel from extreme compression edge to centroid of compression steel. Now, last class I told you, I will tell you next time how this came. Okay, I explain here. Not a big issue. See, somewhere here I'll write, those who are interested. Compressive strain diagram, suppose BM is sagging, will come like this. Okay. This is 0.0035. This distance is XU. So, from here you come down by distance of D dash. 1 minute. Camera visible? I should check it. Sometimes what happens is, suddenly goes out of camera. Oh, beautifully visible. Come down by D dash. That is what? You came to centroid of compression steel. Next time, see, when I give sketch, you can make out. This will be what? This will be XU minus D dash. D dash. Not visible means I write here. This will be, it is small I am writing because D dash. Now, this is strain diagram for concrete. This is compressive strain in concrete. This also is what? Strain in concrete at the level of centroid of steel. I will call EC dash. You write here. This is strain in concrete because this is a strain diagram for concrete. Strain in concrete at the level of centroid of compression steel. Now, similar triangles will give you epsilon C dash divided by XU minus D dash equal to 0.0035 divided by XU. From there you got, 1 minute, sorry, still not ready, something is there. From that you got epsilon C dash, compressive strain in concrete at the level of centroid of steel equal to 0.0035 into XU minus D dash divided by XU. Some will tell, sir, same you wrote there, wait. You told for steel, I will tell wait sometime. This is compressive strain in concrete. Now, there is a term called strain compatibility. In the regular class, I told so many times, composite section, at any level, strain in both materials are same. Therefore, you are right. Same will be strain in compression steel. Okay, that is epsilon SC. That's how you got epsilon SC equal to 0.0035 XU minus D dash by XU. Okay, I'll remove that one. Later, you can take a screenshot and maintain correct. See, I written the board in such a way that if you take a screenshot, everything will be clear. Notes you write later. Okay, now start. This is over. This is a formula. Now, one note in the class. See, dot. I'll come to dot here. I already told it. In IS code, this formula is given. That formula given in IS code is for design purpose. When you go for design, you will take XU equal to XU max. You will see later in design. Therefore, IS code told it is actually what? Strain in concrete in epsilon SC, strain in steel in compression steel, or strain in compression steel is 0.0035 into XU max minus D dash by XU. So make a note. This I told you last time also. In IS code, it is for design purpose. So where we wrote XU, they replaced by XU max. But remember, for analysis purposes, you cannot use it. Some people are using IS code version, they will put XU max here. It is wrong. Utterly wrong. Why? I don't want to bargain now like that. Therefore, remember, you do not consider that max. You write XU only. Write a note here. By chance later, if XU equal to XU max, substitute XU equal to XU max. So what? See, if XU is less than XU max, XU should be as it is. Therefore, be careful. Over. That note also over. Now write here. Now, you write what I am telling. Now, examples coming up. Examples coming up. Oh, spelling problem. Okay. Coming up. One very important. Once if you understand correctly everything now, 4 examples are there. 1 and 2. 1A, 1B, 2A, 2B. 1 is for mild steel, 2 is for torch steel. Torch steel means it can be either FP415 or FP500 or tomorrow who knows, FP550 may come also. Okay. Now, I will dictate the question because space is not there. See, there is no space here. So, see, this will remain same throughout the class. You take 4 times screenshot. You get 4 solution. Advantage for you. All the 4 times you are getting result with full statement. Sometime in the class I will tell. When I do second time, write everything. Nobody will write. They will tell, sir, already written. Or they will take Xerox of that one. Okay, left to their choice. See. Now, I am dictating the question. Remember, start. One important note. Before I dictate the question, you make a note. Now, he is going to give value of F. See, what I told you should write it. If you don't write properly and randomly substitute, tomorrow doubt comes. Little cold I am having. If little doubt comes, you are only responsible. What all I tell you have to strictly follow. Therefore, this all you don't have to write now. What I told little cold I got now. Don't write that one. Now, write some note. Before writing the question, write some note. He is going to give 4 questions now, one after the other one. Instead of 1, 2, 3, 4, he is called as 1A, 1B, 2A, 2B. Why? 1A and 1B is for mild steel, 2A, 2B for torch steel, to understand correctly. Further, in the question, he will give what? He will give what is the epsilon SC to be considered, or that is the epsilon SC calculated, which while solving a problem, you will be knowing it. See, during analysis problem or design problem, as you go further, a step will come where you will write epsilon SC equal to so and so. Substituting, we get the answer. Yes, this is that answer. So what is going to give is epsilon SC calculated. How we gave it? That I know how to give. See, there is a range is there. One on the proportionality limit range, one beyond. How much is my choice? But once you get, when you solve a problem, it will come correctly there. Okay, start. Question number 1A. Write correctly. Question number 1A. Right. Find design stress. Sorry, not design stress, because I refer IS code. I don't use design stress. Find stress in compression steel, that is FSC, to be considered if strain in compression steel is 0.00092. The steel used is mild steel. Remember, mild steel. Over. Question 1A over. Start. Solution. You write all these. Example 1A given. Strain in compression steel, epsilon SC 0.00092. That is now class. This value I have given. Later, you will be when you solve a problem, it will be calculated there. This is our epsilon SC calculated for us. Okay. Start. Now, yesterday I told thoroughly procedure. Now you have to refer it. Now nobody should question me. Sir, why that way? Why means go back to yesterday's class. So start. For refer IS code, mild steel, FY 250, figure 23B, I told. E of steel is given there 2 10 to the power 5 Newton per mm square. We have for mild steel, what you have to do? First find, yesterday I told procedure for you. Epsilon SC at a proportional limit. To save the time, you will write epsilon SC PL, Fy by 1.15 ES. This all explained yesterday. Fy by 1.15 ES comes to 0.00109. Then what I told? Then compare the epsilon SC calculated 0.00092 with epsilon SC at proportional limit 0.0000109. Then I told you, if the calculated epsilon SC is less than the proportional limit value, then no graph, nothing required. Directly FSC equal to whatever is the strain in steel, epsilon SC into Young's modulus of steel, 0.00092 calculated value into 2 10 to the power 5. Answer is 184 Newton per mm square. Question number 1A over. Okay, now start. Question, now only write. Question 1B. I don't want to waste time. 1B. Write the question first. I'll dictate. Find, once again same thing. Now I want to waste the time telling every time what? Find stress in compression steel to be considered. I will tell you FSC. Okay. You write fully. Okay, right. Find stress to be considered in compression steel, that is FSC, if strain in compression steel calculated is, I am giving answer now, 0.00214 given in the question, 214. So question is, second question, 1B, first part, second question. You have to find, the steel is mild steel. Once again, start. Steel, mild steel, same figure, Fy all same, epsilon SC proportional limit will remain same, 0.00109. Compare epsilon SC, second question it is, calculated is, how much given? 0.00214. Oh, it is more than epsilon SC proportional limit. Therefore, I told you, if the strain is more than the proportional limit, then not this way. Your FSC equal directly Fy by 1.15. That's all. Equal to 250 by 1.15 equal to 250 divided by 1.15 is 217.39 Newton per mm square over. Question 1B over. Okay, now this is also over. Now I will give next question. Once again you write full everything. See, somewhere here you have write the question. You have write the question somewhere in between. Okay. Question 2. Now question 2. Question 2A. I will dictate. Find FSC if strain in compression steel calculated is 0.00114 and steel is, I'll tell you steel. The steel is given tar steel of grade Fe415. Therefore, remember later Fy equal to 415 Newton per mm square. Remember, same procedure. If they give tar steel of grade Fe500 or any grade, value will change. Okay, start. Question is what? Find FSC if strain in compression steel is point. You should take screenshot afterwards. Still I have not corrected everything. See, previous values are still there. I have to rub the values. You don't take screenshot now. Once I finish writing, then you should write. Don't copy at this time wrong values. So now see, you have to find FSC for strain in steel of 0.00114 and it is told that what? It is question 2A. Forgotten. Question 2A. It is told that tar of grade Fe415 used, Fy415 I told. Okay, over. This is the given question. Start. Now, our question is given strain in compression steel 0.00114. That is Epsilon SC calculated for us. Refer IS code. Remember, it is tar. Therefore, figure number 22A. I told you upper figure. Figure number 22A, that it will go this way. Some curvature is there, go this way. Same for either tar of 415, you make a note. Don't tell me, sorry, you are not told for 500. Then leave the class. Here Fy 415. Tar means 500 means use 500. 550, use 550. Okay. 22A, Fy 415. First what you have to do, same as mild steel, first find Epsilon SC at a proportional limit. But one change is there. Remember, I told last time, if it is tar steel, 0.8 Fy. I told you last time. See, this 0.8 is to be used for tar. For mild, 0.8 is not there. Why I told in the class? 0.8 Fy by 1.15 ES equal to 0.8 into 415 divided by 1.15 divided by 2 10 to the power 5 equal to, I think I know the answer. It is I know the answer because it is a standard value. 0.00144. Okay, check it. 0.8 into 415 divided by 2 10 to the power 5 divided by 1.15. 0.00144. 1 minute. Camera. Safer side. Okay, done. 144. Okay, now start. Now next step. Therefore, Epsilon SC calculated, how much I told the answer? Given question, 0.00114. See, 114, this is good thing, 0.00144. So be careful. Given strain is 0.00114. Limiting strain is, limit is 0.00144. Therefore, Epsilon SC calculated is less than. So, see, first question, mild, it came lesser. Second question, same one, mild, it came more. Third question, tar, it came lesser. Next question, tar, it will come more. everything over is less than this one. So remember, make a note. I should not tell this one. When even for torque steel, you can make this all told yesterday. Make a note. Even for torque steel also, if the strain calculated is within proportionality limit, then direct answer FSC all told last time is directly epsilon SC into ES. But not for next step, for next case. If the strain is more, then you cannot use the like mild steel. Equal to 0.00, how much I told? 114 into 2 10 to the power 5. If this much clearly told, if not clear means I cannot comment on that one. Oh, not 33. 0.114 into 2 10 to the power 5 is 228. 228 Newton per mm square. Question 2A over. Now, last question. Right here. Last question. Question 2B. Most, remember, right here. This is the most important question. 99.9% problems, you require this one. Make a note. 99.9% problem, practically, mild steel is not used. But academically, I cannot tell. Academically, 70-80%. Why? Rarely they can give mild steel. Practically, for torque steel, see, this case will not come. I know it. This case will not come. Your strain will always come more. Therefore, I have given for procedure purpose. Over. Now, start. Question 2B, most critical question, very, very important. Find FSC for a WI in post section if strain in steel is 0.00. 1 minute now. Before giving, I should set the question. 1 minute, I'll set it. Instead of random, because otherwise it will take a little more time. I will take my calculator, calculate some strain and give. Just wait a minute. I am not changing the question. I will set the question so that you can use this one, and table also you can use. Wait for some time. Not wait. You will see it immediately now. Okay. Now I set the question. I made some values here. See, this is not for you. It is for my personal reference, because here, as I move, problem will come. I cannot open calculator again and see the tables or my table. That paper is so torn out, therefore not possible for me. So this is not for you. Don't see that one. Do not see that one. This is my own personal note. Okay, now, right here, question, write some. Okay, question 2B. You write not that way. You write example, see, 2B, most important. Practical design point of view, 99.9999% or 100%. Academic point of view, say 90%, because even nowadays, in exam also, mild steel they are not giving. But some gate exam or some places I have seen, they suddenly give mild steel. Okay, leave it. Anyway, mild steel is so easy. And torque steel, last time what happened? See, you got lesser last time. Less means direct answer. There is no confusion. For both mild steel and torque steel, less means strain into Young's modulus. If it is more for mild steel, no problem. Why? Fy by 1.15. That's all. But torque steel, some numbers are, see, torque steel also, it is Fy by 1.15 only, but into a number will come. Some number you have to search IS code, or you have to refer SP16. That's why most critical question, write the question once again. Now see, some portion I have to remove now here. So once I write everything, I will remove. So every time you start from here only. Every time start from here. 4 times write. Okay. Find FSC. What is FSC? I will not tell. If strain in compression steel calculated value is 0.00256. Usually when you calculate, up to 2 zeros will come, guarantee will come. Why? Because extreme is 0.0035. It has to come lesser. So it is 0.00256. So 3 numbers I will write, 256. That is epsilon SC calculated for us now. Question 2b, most important. Steel is tar of grade Fe415 once again. Today's class 415. I will tell you afterwards for other steel. 415, over, start. Refer IS code, given. No, refer IS code later. IS code, tar steel. So figure 22A, that is upper side. Okay, tar. Given, tar of 415, Fy415, E is standard. First calculate epsilon SC at proportional limit. Tar steel, once again 0.8. So same answer will come. Why? I am changing the calculated strain. I am not changing other property. You write once again 0.00144. Therefore, epsilon SC calculated is 0.00256 is what? Is more. This is the most popular case. I told practically 100% more than epsilon SC at proportional limit 0.00144. Now you cannot do this way. I will tell you now what to do. See where I kept it. That rubbing part is usual problem. Here. Now see, now this will go. So do not copy now. If you take a photograph, take at the end of the class photograph or screenshot. Any old values are there? Because it should not be there. Nothing is there. Okay, now make a note. Make a note. For this, when for tar, you should write what all I dictate, you write here. Because this is almost 100% required. What all I tell you right there. Some note. We are in tar steel. That is the most popular. And our strain came more than what? Proportionality limit. That means if you see the curve here, it will go beyond that one. You are in the curved part. Right here. We are in the curved part. See figure 23A. We are in the curved part. Now, you have two options. Option 1 is use IS code. That 23A, use it. Option 1. Option 2, other option is use SP16. But remember, make a note. IS code can be used for tar of 415, tar of 500, even if tomorrow tar of 550 comes, unless IS code changes, same. See, it is told only, it is given in terms of FY. See, therefore, does not matter whether it is 415 or 500 or at present as per IS code 550. So, IS code can be used for any tar steel. But you should, if you are serious, you write it. But, this all right, but. Second option is SP16, which is very, very easy. A table is given where a strain above this value, below they are not given. Why? If the strain comes below this value, you know the answer. See, last case, multiply by Young's modulus. A table is given starting from this strain to get, for different strains, how to get FSC directly. In the SP16, table A, page number 6, I think most probably. Okay, I told last time. But one problem. SP16 has published the table only for FE415 and FE500. Actually, at present, popular steel is FE500. You can use it. But tomorrow, in case FE550 comes, then if they include in the SP16 table, okay, well and good. Otherwise, what to do? If FE550 is there, no other way, you have to use IS code only. So, first option is, see, write a note. We have two options. Two options. Namely, one dot, use IS code. IS code 23A. Right here. Can be used for any grade of tar steel. Tar steel. We will use it now. Any grade. And option 2 dot is use SP16. But
can be used only for FE 415 and FE 500. This much you write. Okay, now I want more space. I am removing everything now. See, this full I am removing. So this much you take a screenshot. Okay. Now, then you have to write. So this I will remove now. First time statement I am removing. Okay, now I will go to option 1. I will go to somewhere here. Okay. Option 1, right here. Option 1, 1 dot. Can be used for what? Make a note. Can be used for any grade of torch steel. Right now we are considering, don't ask me, we are considering FE 415. Someone will ask, sir, FE 500, write FE 500. I will tell that way. And use FY equal to 500. Why you are asking me? See, when you refer the graph, 415 will not come. Okay, FY, start. See now, what to do? 23A. See, correctly what I am doing. One thing now, see, it is very difficult to get the exact value. You make a note here. Very difficult to get exact value. Therefore, slight approximation will be there. Helpless. See here, strains. If you see, this is the strain. Strain, that is epsilon SC. This way is the stress. That is our FSC. Okay, start. Point, our strain is, you write somewhere. Actually, already written. Our strain, not our strain, for this example, strain epsilon SC equal to 0.00256. Okay, start. 256. Somewhere here you can see 0.002. See, you can see 0.002. Little further you can see 0.003 somewhere here. Little further you can see 0.004. Actually 0.004 is useless, because when the extreme fiber is 0.0035, intermediate cannot come more than 0.0035. Now see what to do. 0.002, 0.003. See what I am doing. I am telling something to myself only. 0.002, 0.003. As clear. See, or you have to do one thing, make a note. This page of IS code, take a big Xerox of this size. Then you get accuracy. Or little later in the next class, I will tell the advantage of the approximation. So, I won't tell anything. 0.0025. It is 0.0026. 0.002, 0.0025, 26, 0.0025, 0.0026, 27, 28, 293. Okay. See, there are some lines like this. Don't see those lines. Vertically you have to go up. Okay. Which one? From a strain of 0.00, how much it is? 256. See, 256 is 25. Approximately go there. 0.0025. See, little error, nothing can. This is a line. Now, see here, where it cuts the, actually I told you, one curve is for Fy curve, other is Fy by 1.15 curve. Last time, you have to actually use this one. But for this curve, values are not defined. Use Fy curve, but never forget to divide by 1.15. So, if you see Fy curve, if I see here, here is the point of the 0.0026. See, the curve will go something like this. I don't put the curve here. 0.00256. It will go something like this. Okay. Then little down. Okay. This is what Fy curve. You should not use it. Okay, no problem. Now, correctly come this side. You take the IS code. Now, see the lower number and upper number. I already know what is. See, now, I should do correct clear. I require scale, etc. So, you try it yourself only. If you see correctly there, the lower number will be somewhere 0.9604. Okay. Somewhere here you can see 0.95. You can see somewhere here 0.95, bigger I'll write. Somewhere here you can see in still bigger, okay. Somewhere here you can see 0.95 Fy, this point. Somewhere here you can see 0.975 Fy. Okay, now our point is here, 0.995. I will decide now. Imagine it is here, okay, here, okay. 0.95, around 96, still no. I think I should come further down. Imagine here, okay. 0.95, 0.96, 0.96 means 0.975, 0.97 approximate. So slightly above 0.96, not too much above, slightly above. Okay, I will tell, say that number is 0.96, slightly more, 961 I will tell. So now I will write, referring to IS code, figure 23A for epsilon SC strain of 0.00256, we get FSC equal to, see, somewhat approximate, not exact value, little approximate, equal to, how much I told? 0.961 into Fy, but never forget I told, you use the curve, which one? You used Fy curve. You should use actually Fy by curve. So never forget I told, that chance of making mistake. There is red color. Okay, red color is not available here. To make, okay, I use a color. Never forget, divided by 1.15. If you forget means problem. Okay, start. Now over. See, these things all you cannot explain in the class in the systematic way. See, disturbances are there. Equal to 0.961. Our Fy is 415. If 500, put 500. If 550, write 550. Okay. Divide by 1.15. Therefore, we get FSC equal to answer. Or equal to, I'll put here, equal to 0.961. 0.961 into 415 by 1.15. 346.8. First decimal is sufficient. 346.8 mm square. Therefore, for epsilon SC equal to 0.00256, epsilon SC calculated, we got FSC equal to 346.8 Newton per mm square. Write the answer. Over. Remember, this you can use for any grade of steel. No restriction. Okay. Now, 1 minute. I should see the timer of the camera. After some time, recording will stop. I will be little careful. 1 minute. I will rub the board so that I will write. Otherwise, what happens is time problem. Okay. Now write. Option 2. Use as I already told when you can use it. Only can be used for FP 415 and 500. See, table A, page number most probably 6, search it. To get FSC for epsilon SC equal to this one, for Fy equal to how much? Fy equal to 415 Newton per mm square. Therefore, refer the table for Fy equal to 415 Newton per mm square. See, the starting value you can see 0.00144. Why? Limit. But we got 0.00256. It lies between 0.00241, 276. Values are given. Now perform linear interpolation. I already calculated. It comes to 346.7 Newton per mm square. See, I already told you. By IS code you got 346.8, 346.7. Okay, write the answer. Now make a note. One note you write. When he used IS code, he got 346.8. Now by SP16 exact value, by linear interpolation, he got 346.7. Therefore, almost same. But there is something hidden. I decide before I solve the question, when I used the IS code, I decided what number should come to get that answer. So, because I can't see that, I cannot read properly. So, it is actually, someone will tell cheating. In the class, students will tell, sir, we know, sir, what you have done. See, what I will do is, I will say, take IS code and I will tell this way. 0.961. They know that I am using a trick only. But anyway, you may not get 346.8. If you get 347 point something, 345 point something, no problem. That much approximation is agreed. See, when the IS code has given this curve, approximation is permitted. Okay, that we will discuss later. Now, one small note. In SP16, FSC values are given based on D dash by D value. Someone told, I can use it. Use it if possible. How to use? You are not told. D dash by D I are not given. I will tell for 0.0256, tell the strain, stress in steel. No, I require D dash by D. How? That means that D dash by D table cannot be used for analysis. It is only for design. In the regular class, I will tell them, I will explain there why it is based on D dash by D. For you, do not use that one. Okay, now thoroughly study everything. Next class you are going for analysis problem. There, FSC calculation, I will not explain. I should tell stern voice only. Why? This much explain. Furthermore, I don't think anybody can explain more. Okay, thank you.